everyone for coming. Sorry. Yeah, slightly different maybe than Mel. So we're going into a bit more like BIM in practice, Revit particularly. Why isn't this working? Not to worry. I know some of you quite well. I'm with FenestraPro. We're an Irish-based software company. I'm an architectural technologist originally. Then, like a lot of people, I went on and did a master's in environmental design and energy studies. A number of years ago, myself and a colleague, we started looking at facade design and how it impacts the energy performance of a building. We were doing a lot of this, a lot of research as architectural technologists, I suppose. And then over time it became like, oh shit, this is kind of interesting. And people were sort of saying, what if it could do this? And what if we kind of fed this sort of stuff in? And we got involved with Autodesk, I suppose, long story short. And over the last few years, we've had quite deep ties with the Building Performance Analysis group in Autodesk. And we've been doing quite a lot with them around the energy analytical model in Revit. One of the last things Mel said there, he talked quite a lot about cost, and one of the last things he said was, and carbon. Do you know what I mean? And I think more and more carbon and energy performance of buildings is becoming like a really hot topic. Well, it already is, right? And not enough do we look and analyse the energy performance of our buildings and how much carbon they use in the design process. And one of the reasons behind that is Revit, right? Like one of Revit's greatest strengths is one of its greatest weaknesses. It's a huge mammoth of a software. It's very difficult to do things. There's about 100 different ways to do the same thing. So therefore we get a lot of imperfections or diversions between the way one person does things to another, right? So what we're trying to do is just sort of give people a sense of ways to tackle energy performance and energy analysis at different stages and the different types of analysis. So I'm actually doing this class for Autodesk. I say class. It's a class for Autodesk University in November, right? Mid-November, I'm going to be doing this. It's a 60-minute class, but I've got to record it tomorrow. Okay, weirdly, like mid-September it's got to be, so it's kind of finished. So what I've tried to do is condense a 60 to 90 minute class into a 15-minute presentation. So Barry, if you can just let me know if I'm running over, right? So I've haven't, this is seat of your pants stuff. Let's give it a try. So basically what we'll be doing is looking at the Revit energy analytical model and how it solves problems, or how it solves, or how it looks at analysis for total carbon, and we'll get onto the total carbon side. We'll look at a couple of workflows and effective workflows and why we need to use them in Revit for energy analysis. We'll just touch on FenestraPro, not hugely, because like I said, this is very trimmed down, but I will touch on it once or twice. This is definitely not something I'm touching on, where we are going with FenestraPro in conjunction with Autodesk and lots of stuff we're doing, but like happy to talk about it and questions or whatever, So let's talk about building energy analysis first. And like it's a tricky one, because I think a lot of people can be very much like, well, this analysis is right, or this is wrong, or what's the, my model needs to be perfect, and but like as we all know, analysis, there's no right way of doing analysis. It depends on the question you're asking, right? It depends on how much resourcing you want to put into that question, how much time you have, how much information, all of that kind of all that kind of stuff. And as the man said, all models are wrong, but some are useful, right? So that kind of speaks to analysis, because in this domain, I suppose, we know we're driving towards energy performance and ultimately carbon use, and also for the occupant comfort in a building. But like there's lots of stuff that surrounds that. We can do lots of different like individual little pieces of analyses, like solar analysis or wind or comfort or whatever. There's millions of different like things that I've listed there, but then there's many more, right? So one piece of analysis on the embodied carbon of your materials does not mean it's the full analysis of the building. You're just looking at one particular piece. Or in our case in FenestraPro, it's looking at the solar heat gains in a space, or the thermal performance of an envelope, or whatever that might be. So there's lots of different ways to approach analysis, and there's lots of different objectives, and there's lots of different ways to go about it. So if we think about like there's different types of analysis, and this is kind of my take on it, Other people might have different ways of kind of bracketing or putting these things in buckets, but we might have a feasibility analysis that might be very early stage. We're looking at climate or the orientation of a building on a site or whatever. We might be looking at optimization, maybe something a little bit more. We're looking at, what's my facade or envelope fenestration? What's the optimal solution around that? Or what's the optimal material, selection? We might be certainly, well, very often we'll be looking at documentation, right? In other words, compliance checking, running lead analysis or deep or whatever else. There's loads of different methodologies. And then maybe later on validation. Okay, validating our building designs against what's getting built. Now, I've kind of, again, this is my interpretation, and I've just put them in a way that we might be familiar with those things, right? So feasibility might be very early stage, documentation, validation might be very late stage. But that's not to say that they have to happen there. You might be doing a quick study on changing this type of glazing to that type of glazing at construction stage. You know what I mean? And you might want to do something very quick, but you have this beast of a model in Revit, right? So you talked about a lot, the information. How do you do something quick on a dirty big model that is coming from loads of different consultants and stored in loads of different places with loads of different pieces of information or lack of information? And that's kind of what I want to get at here, because there's lots of different ways to do that in Revit. There's what we call the energy analytical modes, or approaches, I suppose, levels of information, and what's the right way and what's the wrong way, or what's the optimal way, I suppose. So let's talk about the energy analytical model itself. What is it? Well, we take the Revit model. We have an architectural model, say, or structural model, or whatever else. As I said, loads of just information. What Revit will do is drive an abstraction of that information into a layout, some into some data that it can understand from an energy performance point of view. So key paths and processes of heat transfer. So what are the external surfaces? What are the internal surfaces? What properties do they have? And that information, that energy analytical model, or EAM as we call it, and I'll keep saying EAM from now on, that is used in Revit for things like systems analysis. I don't know if anyone's familiar with that, but that uses Energy Plus, for example. Or we can use it in DO2, or these kind of energy analysis engines. Basically what Revit does is it takes the building information, empties it into a piece of data that can be run through DO2 or Energy Plus or whatever. So there's two components to that. There's analytical spaces and surfaces. So spaces is this volume of space. It's the room itself. It's like, what is happening in this room? What kind of use is it? How many people are going to be in it? All of that sort of information. But then we'll also have the surfaces. So as I said, paths of heat transfer, how much heat has been lost through that wall, how much heat has been gained through that window, etc., etc. So there's, as you can imagine, quite a lot going on there. And particularly in a big model like this. So this is called Snowden Towers. I think it's in Pennsylvania or something like this. This is Autodesk's current kind of sample architectural model. Yeah, there's loads of crap in it. Well, I mean, it's a pretty good model, right? But there's lots going on, But to run an energy analysis model, basically what we're doing is we're going to the Analyze tab. There is this energy, the Analyze ribbon. There's this energy tab with a number of things. Energy settings being one of those buttons, and we can set loads and loads of different things, right? It's dirty, in terms of the user experience. It's just there's so much going on. It's really confusing. Do you know what I mean? There's loads of these different modes. There's tick boxes on and off. They know it's a disaster. We're looking at wizards and workflows with them to improve that user experience. But this is Revit 24. This is the way it is at the moment, right? So the first thing we'll see is there's a couple of different modes. So building elements, conceptual masses, and building elements and rooms or spaces. If you go back to Revit 22, there'll be 4 there, right? And those 4 look something like this. There's conceptual masses. It's gone. It's retired. It's a load of shit, right? It doesn't really work. There's building elements. It's legacy. They're not changing it. It's still there, but they're not doing anything with it. This is the current one that they're really pushing, conceptual masses and building elements. I'll talk about how that's created now in a second, but the long story short is it's quite high speed. High speed in terms of what you've got to put into it to run this analysis, but it's lower precision. Okay, back to my point is like, what's the question you're asking? What's your objective? How much time do you have to put into it? How much information? But then there's this other mode, rooms or spaces. It's a little bit more user buy-in, user kind of manual heavy lifting in terms of the model. But the point here is it's much lower speed. It's going to take you much longer to create this in a model, but it's much higher precision. So which to use, how to use them, that's the kind of, that's the rub here. And if we go back to our kind of workflow and my kind of buckets that I mentioned, the conceptual masses and building elements, if anyone knows of the massing tools in Revit, it's really quick, really easy. You can create these spaces and volumes and forms really quickly. And it's brilliant for really early stuff or even quite late stage stuff that you can create forms around it. So therefore, it can be used from the earliest stages in a project right through really up to kind of when you're on, in construction. Whereas the rooms or spaces method, it's quite detailed, loads going on, so you're certainly not going to be able to take an early stage model and use it. So we're kind of saying, from the detailed, design development stage or LOD 300-ish, onwards. And just to talk about those two things, I'll skip through this quite quickly. How many do for time? Am I 10 minutes in?
Yeah, you're 12.
Okay, so skipping through it quite quickly. What happens is the key difference here. Does anyone know Minecraft?
Yeah.
Minecraft, yeah. So the conceptual massing and building elements basically uses Minecraft. So it creates a voxel in this space, and it will see that there's a little kick in the ceiling, and it will see there's a kick in the ceiling over there. But if you have like a funny complex built, room, it's gonna create a volume within that room, and it's really good for that, right? It can iron out gaps in the facade. It can, make assumptions. It's really, really good, but it's not as detailed. Whereas your rooms and spaces, I'm just skipping through the pros and cons because I'm going to take too long, where your rooms or spaces is based on just that, Revit rooms or spaces. Now, a Revit room is just like you create on a 2D Revit plan and it's going to extrude the height, right? It's not going to pick up that kick in the ceiling. It's not going to pick up a mezzanine level, all of that kind of stuff. And in fact, because it's a room, there's no information except for the name of the room and the area. A space, on the other hand, does have some analytical information. Same thing, created on a 2D plan, extruded up, not going to pick up that, not going to pick up a mezzanine, but it will have, this is a conference space. There will be 18 people in here. There is this kind of lighting. There is this kind of mechanical systems. So there's quite a lot there, you know what I mean? But like, the point is that you have to have quite a detailed model to create that, to run that energy analysis mode, So if I look again at this Snowdon Towers model, here's a little bit on FenestraPro. This is something that we have done, over the last while, is basically take that model, and what we're doing is identifying the energy and analytical model problems on it. So we're visualizing the architectural model, but down the side here we're saying, the walls don't have U values, and your glazing doesn't have U values, and there's a gap in this facade, and there's no roof, and there's whatever else, So I'm going to skip through this now in a second, but like, the point is that it's very visual. We're trying to take what Autodesk has done, and with this really kind of honky looking user interface with their energy settings, and we're trying to visualize it and show it a little bit more in a kind of a user experience kind of way. So the reason I point that out is this Snowdon Towers model, as you said, Mel, it's like loads going on. There's floors that are roofs, there's gaps in the facade, there's no U values on the walls, etc. So you're not going to run a good energy analytical model from that. So here's a couple of ways you can. I'll skip this workflow. This is just a basic conceptual mass, if anyone knows it. But I'm going to do the same. Let's go to the next one. I'll do the same here. So I'm going to take that Snowdon Towers model. I'll bring it into an EAM Revit template that we've set up that has views, gets rid of all your site context, your landscape, and all that crap that's in the model that I don't want to know about from an energy analysis point of view. And I just get left with this view, which is basically your skin, right? So we have a building, we have these, floors that are roofs, we have walls with no U values, etc. So what's a really quick way to do that? Well, using the conceptual massing, I can just literally draw a box around it, right? Draw a mass, create, the heights and the different spaces from that. And then using new stuff, new features in Revit 24, like you don't have to, it doesn't create an energy analysis model from everything in the model anymore. You can create it from views, you can turn things off really effectively. What I get left with is this mass over the form of the building that I can run energy analysis on the conceptual mass, right? It's really, really simple, really, really high level, not a huge amount of kind of detailed information. But the point is, that took me like 5 minutes, right? You know what I mean? So if I don't have the time to get into the weeds with this energy analysis, there's one really effective way of doing it. And another way, am I okay for?
No, you're
okay.
Yeah, it's about
okay.
a minute.
One more minute. Okay. Okay. Another quick way is, and I'll skip through some of this, is taking that mass and starting to put some detailed elements to it. How do I skip forward? Okay. The irony of being in a tech company now is tech is my worst nightmare. Anyway, I'll skip past this one. But basically what I can do in Revit as well is take that mass and start adding elements to it. So again, I'm disregarding the linked model, the original Snowdon Towers model. I just have my analysis box, right? So I'm starting to add some walls to the mass. I'm adding some roofs. So again, I've slightly more information. Again, it's not a deep analysis, but it's a quick analysis. And then lastly, I'll just skip past this one. This is next gen insight. So going back to carbon, right? Total carbon. So now I have a scenario where, I've built up my levels of analysis. I'm looking at this Snowdon Towers model, and I can, do loads of stuff with it, and bring each of those kind of levels of analyses up. But there's features in it that we can set the material properties of all the information in this building quite quickly, create my energy analytical model, and now bring it into next gen insight. That's what they're calling it, right? If anyone's familiar with insight, it used to be just operational energy. Now it's total carbon, so embodied carbon as well. So we're looking at our operational carbon, but from the detailed elements of that building, we can start getting the embodied carbon of my walls, my roofs, my floors, etc. Quick bit on FenestraPro, and that's me done. But this might just a little ad if I can for 30 seconds or so. Why is the music on? Okay. No, but look, I suppose, as Mel said, look, it's all about carbon, really, and, analysing carbon. But Revit being Revit, it's very difficult to do that in the energy analysis model. So we've just created these new workflows and new kind of ways of looking at, whether it's, FenestraPro itself, looking at the facade and the thermal performance and heat gains in the space, or, systems analysis in Revit, or insight for, with Autodesk, etc. The route to that is your energy analytical model, and there's lots of different ways and lots of different levels of doing that. I've tried to take that 60 minutes of that and put it into 10 minutes. Not easy, as I just found out, but hopefully that gives you a sense. I don't know why my video's gone, but it's getting a little bit ropey here. Hopefully that gives you a sense of it. My thing is gone, but yeah. If anyone wants to learn more, there's a little QR code.